Hello, and welcome to an intergalactic journey to Io, Jupiter's moon. I'm Cecilia Fior. So, a short introduction to Io. It is one of Jupiter's 67 known moons. It was first observed in 1610 by Galileo, along with Ganymede, Europa, and Callisto. It is the most volcanically active celestial body in our solar system, and this is because Jupiter's gravitational pull on it, as well as neighboring moons Ganymede and Europa. So as a result, the surface is covered in hundreds of volcanoes. So some similarities between Io and Earth. It revolves Jupiter in an elliptical fashion, creating similar but stronger tidal forces than we have on Earth. So like our ocean's tides come in and out, lava on Io is constantly moving. It also has a possible iron core, just like Earth, meaning it could have its own magnetic field. As a satellite, it has a similar size to Earth's moon, and it is made up of silicate rock, although mostly in liquid form, which makes up most of Earth's crust. Some differences. So there's a lot less gravity on Io than on Earth. It's only about 1.8 meters squared, and Earth is 9.8 meters squared. So if you weighed 150 pounds on Earth, you would weigh almost 28 pounds on Io. It takes about 42 hours for Io to orbit Jupiter and also rotate on its axis, so it's about a day and a month all take about 42 hours. Volcanic plumes can raise up to 200 kilometers into the sky on Io, raining ash and sulfur on the surrounding surface, and as a result, it has a sulfur atmosphere but also areas of sulfur frost. So some challenges associated with Io, it can reach 2,000 degrees Celsius closest to the volcanoes, and mine is 143 degrees Celsius furthest from the volcanoes. The surface is mostly lava. The atmosphere is largely sulfur dioxide, which is very toxic, and there's little chance of life existence because of the harsh environment. Not even Earth's extremophiles could survive in the hottest areas. So overcoming some of these challenges on Io, we could send a satellite made of strong metal alloys such as tungsten and nickel iron, which has a very high melting point and would not melt upon impact with the lava. We could land on nearby Europa, which is another one of Jupiter's moons, and it has an icy surface. We could orbit Io in a spacecraft. We could also create a futuristic spacesuit, which would withstand the extreme heat while maintaining human oxygen levels. So why would we visit Io? The possible discovery of a moon with an iron core. Earth's iron core dictates its magnetic field and its gravitational pull. It would be interesting to see what kind of effects it would have on a moon versus a planet. We could study the intense gravitational pull's impact on volcanic tides. Is it similar to that of water on Earth? Is it stronger? We could better predict Earth's volcanic eruptions, so if there's tectonic plates on Io, we can understand why volcanoes erupt when they do. We could help predict when some of Earth's volcanoes are going to erupt. We could understand why the moon is not cooling despite the intense release of heat. So when a volcano erupts, it obviously releases, a lot of heat, and obviously the planet is not cooling down because it is still covered in lava. So why is it not cooling down? Is it the gravity? Is it the way it's positioned? We could also study the ground to assess its age. So within the sulfur frost, we are likely to find other elements, and we can help identify how old Io is based on these elements and their half-life. We could also understand how its unique temperatures cooperate. So obviously there are areas of extreme heat and areas of extreme cold with the result of frost. How does this planet work like that? Like the gravitational pull obviously keeps the lava flowing, but why is it frozen in some areas? It would be very interesting to find out. And that's why I think we should visit Io. Thank you for listening and watching my presentation. I look forward to watching yours.